Ever wondered how your email filters out spam with uncanny accuracy, or how your bank detects fraudulent transactions? Well, the answer lies in a concept from the realm of machine learning known as logistic regression. Now you may ask, what is logistic regression? Simply put, it's a classification algorithm used to predict a binary outcome based on a set of independent variables. But let's not get ahead of ourselves. To fully appreciate its operation, we need to understand it step by step. Firstly, we have the concept of regression. Regression, in the simplest terms, refers to predicting a continuous outcome variable from one or more predictor variables. For instance, predicting the price of a house based on factors like its size, location, and age. But what if our outcome isn't continuous but categorical? Like predicting whether an email is spam or not, or whether a transaction is fraudulent or not. This is where logistic regression comes in. Unlike linear regression, which uses a straight line to model the relationship between the predictors and the outcome variable, logistic regression uses the logistic function. The logistic function, also known as the sigmoid function, has a characteristic S shape and can take any real-valued number and map it into a value between 0 and 1. This means it's particularly suited to situations where our outcome variable is binary. That is, it can take only two values, 0 or 1. The process of logistic regression can be broken down into 5 key steps. Step 1. Collection of data. This is the initial and crucial step where we gather our data, which will be used for training the model. Step 2. Data pre-processing. In this step, we clean the data, handle missing values, outliers, and perform feature scaling if necessary. Step 3. Creating a logistic regression model. This includes selecting the relevant variables that influence the outcome and applying the logistic function to these variables. Step 4. Training the model. The model learns from the data, adjusting its internal parameters based on the logistic function. Step 5. Testing and predicting. We use a separate set of data to test the model and make predictions. To summarize, logistic regression is a powerful and widely used machine learning algorithm that helps us predict binary outcomes. It operates in 5 key steps: data collection, pre-processing, model creation, training, and testing. It uses the logistic function to map any real-valued number into a value between 0 and 1, making it ideal for binary classification problems. So the next time you marvel at your email's ability to filter spam or your bank's knack for detecting fraud, remember the unsung hero working behind the scenes: logistic regression. It's not just a mathematical function, but a tool that helps make our digital lives safer and more efficient every day.